All right, the next type of reaction we're going to talk about is the decomposition reaction. It's exactly like it sounds. Decomposing means breaking down, and that's exactly what's happening in this type of reaction. You have one reactant, so one thing to start with, and it breaks into smaller, simpler pieces. Okay, here's an example. If you took H2O liquid and you give it a little energy, you can make hydrogen gas and oxygen gas. Another example, so you have a flower and it breaks down into the remnants of the flower and the little seeds that float off to repollinate. Another example would be an egg, and then when the egg cracks, you have the broken egg shell and a chicken comes out. All right, now let's look at some actual reactions that we need to predict. So we have CaF2, and we know that the Ca and the F are going to break apart. Now when they break apart, you have to evaluate whether they're diatomic or not. There are 7 diatomic elements. I will briefly remind you if you have forgotten them. Oop. All right, so we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, so there are 7 of them. These 7, when by themselves, will have a little 2 down here. So when you do that, your reaction is now balanced. Let's look at another one. So we have Li and H. So Li and H are going to be separate. Let's see if I can find my little, there it is. All right, so you're going to get Li and H separate. Now evaluate if either of them are diatomic. H is, so you get a little 2. Makes your balancing a little bit more involved, but that's all there is to it. All right, then we're going to look at this one. This one should look familiar to you. But you have H2O, and H2O is going to break down into hydrogen and oxygen, and then evaluate if they're diatomic, and they both are, which means that balancing would look like that. All right, now there are some special cases of decomposition reactions that you have to be aware of. Decomposition of a base, decomposition of an acid that contains oxygen, or decomposition of a salt that contains oxygen. The first is going to be the base that contains hydroxide. So basically it's going to break into the metal oxide and water. So calcium hydroxide breaks into calcium oxide and water. Okay, all right, so KOH would break into KO, and then you would need to balance. So you got 1 plus 2 minus. So that'd be K2O plus HOH. All right, and then to balance, just throw a 2 right there. Okay, the next one, BaOH, is going to break into barium oxide, and you have 2 plus 2 minus. So these just cancel out. And HOH. Okay, and then this is not balanced. That's why our numbers look a little funky. So then when you go, let's see. Nope, that's balanced. Okay, we're good. All right, and then this one, you're going to get lithium oxide, 1 plus 2 minus. So that slings a 2 down there. And HOH, and then a 2 in front there, and there you go. So if you have a base, it breaks into the metal oxide and H2O. All right, if you have an acid that contains oxygen, it breaks into the non-metal oxide and H2O. So in the example of HNO3, you get the N combining with the O, and then the H2O, or the water. So if we looked at the second one, we're going to get the non-metal forming with the oxygen, and then we're also going to get H2O. Okay, all right, now the products of these reactions tend to be sort of different, so you kind of have to memorize especially the nonmetal oxides, which you get. So here from the carbonic acid, or H2CO3, you're going to get CO2 and H2O. All right, here's phosphoric acid. Phosphoric acid, again, another one you just kind of have to memorize, turns into P2O5, so that's the nonmetal oxide, and the H2O. All right, now this is sulfurous acid. Sulfurous acid breaks into SO2 and H2O. Okay, and then this last one, it's very similar to this one, except we have an extra oxygen, and you're going to see that the reaction itself is actually very similar. So we produce the sulfur dioxide, the water, and one other product, which is, you guessed it, oxygen gas. Okay, so these are some that you just have to practice, you have to get better at, you kind of have to memorize what's going on. All right, the last special decomposition is when you have a salt that contains hydrogen. The salt that contains hydrogen is going to break into a metal oxide and a nonmetal oxide. Again, nonmetal oxides can be a little tricky, so you might have to do a little memorizing at this stage. All right, so here we see the lead sulfate. So lead sulfate is going to break into lead oxide. Pb is 2 plus, O is 2 minus, so we just stay like that. And the nonmetal oxide, which is SO2, if you remember from the previous case when SO4 breaks down. And then you also get the extra O2 hanging out there. Okay? All right. The other one down here is going to be sodium oxide. So Na is 2 plus, O is 2 minus. That's why we got that 2 there. And NO2. Okay? So that is what is produced. Plus, again, an oxygen. When you look at the balancing, you're going to have 2 of the salts initially, okay, to get all these oxygens balanced out. Okay, you got 2 there, 2 there. Actually, this one's going to end up making us go into the sky here. Let's see, put 4 there. 4 there. All right, now let's look. So our NAs, we have 4 and 4. 4 N's, 4 N's, and then we have 4 times 3 is 12 O's. 2 O's plus 8 O's is 10 O's, 11, 12, and there you go. We are balanced.